Right, so tutorial 1. Let's talk about sediment systems and marine and subaerial and all the processes and waves and all the energy. So we're going to try and get everything in the context of this bit of coastline here. So there's Sandbanks, Poole, coming along to Bournemouth, Studland and Swanage. So we've all been here, so we've kind of got an idea of what's going on. Oh, there's a big island in here, by the way, with red squirrels on it, called Brownsea Island. So let's think first about sediment systems. So there is a river coming in here, and that is bringing in material that has been eroded and transported from the river. So that is fluvial input. Okay, that's really important because that's bringing sediment through. Okay. Then over here, we've got this hard chalk and it's been eroded. So you've got erosion here, and that material is an input. Okay, and some of that is eroded by the marine processes, the waves, and also we've got weathering on the cliffs. Okay, so all of this is bringing sediment into the system, which is great. Okay, so that's our inputs. If, and we don't, but in the olden days, and not as far down here, we had a big glacier, the glacier might bring in some inputs too. It doesn't happen here, but it could theoretically happen. So we've got to think, whenever we're thinking about the coastline, where is the sediment coming from? There is the possibility as well that sediment might come in from the sea, and that might happen if we had like a little sandbar here, and then we had rising sea levels. It might push some of that sand inwards, and that sometimes does happen. We might talk about that in another tutorial later. So that's kind of our sediment inputs. We've also then kind of got our flows. So if material is transported by longshore drift, it can be moved around the sediment system. And this is approximately the direction of longshore drift here. Okay, so that can happen. We've got longshore drift happening this way as well, moving it along to Bournemouth and then even further on in our sediment system. Then we've also got our outputs. So some of our sediment will be lost out to sea, like that. Okay, it'll go out to sea and we'll lose some of that sediment, and some of it eventually will go out of the side into another sediment cell. So we might lose some out of this way as well. So we've got all of these inputs and outputs in this kind of area. And then we need to think a little bit about our processes. So our erosion provides an input of sediment, and then it's transported by longshore drift, and it's deposited, like the beaches here on Sandbanks, producing our beaches. And so that's how sediment is kind of eroded, transported, and deposited, moving around this system. Now, if we look here in this sort of area, we can see that potentially this is a spit, so it could have formed by the transport, but we see that it's not joined up here. Okay, we've got another potential spit here because this river comes out and keeps like breaking up here. So basically the flow of water has to get out somewhere, so it comes through this gap. This will also erode, obviously, on either side as well. And then over here, when the water comes down, it's much slower, less energy, so we get deposition over here. So we've got lots of deposition over there, and from a sort of biology position, we've got like succession. So material is deposited, we kind of get a salt marsh, and then sort of plants start to grow, and we kind of get more land created there. So that's where kind of sediment is stored in that area. So all of this kind of works together in this system, and we can see here it happening. Now, obviously, we've talked a little bit, and I put up here, we've talked about sediment systems. We've talked about processes. Okay, we'll talk a little bit more about the processes now. So our processes are our marine processes. So where we have the waves, and that can be constructive or destructive, they will affect what's happening. And these are our marine processes. They only act between the low and the high tide area. Okay, so here we can see that we've got lots of deposition because we know there's a beach running all the way along here. So that's going to be constructive waves, and that's because it's quite calm. If we go around here, this area here, we've got a headland, and we've got erosion happening in this location because the waves are kind of forced into each other because of like the headland location. I can explain that a bit more detail if necessary. And we've got our sort of landforms of erosion. So we've got a stack and arch here, quite exciting things. And that's because we've got the destructive waves. So the waves are affecting that, and they are eroding, and then they are feeding into our sediment system because they're providing an input of sediment, which is then later deposited somewhere else. So it all links like the circle of life. And in theory, this is a closed system, but obviously anything that escapes out into the next sediment cell, or that way, I suppose, or comes in from that sediment cell, that would obviously make it an open system, and it is really an open system. For honest, but you could argue in this area it's kind of closed because what's eroded is then deposited. Obviously, that's another way that we've got inputs into our open system as well, and out to the sea is another way we've got it. And you could say, well, it's obviously an open system because we're losing things out there. So we've got these processes, are marine processes caused by the waves, and they cause erosion, transport, and deposition. But we've also got this thing here, our subaerial processes. So subaerial. And that is weathering. So marine processes can only act in the high and low tidal areas because basically that is where the sea is. But higher up we can have weathering like freeze thaw, frost shattering. We can have biological weathering with roots kind of breaking things up. We can have the salt getting in from spray and that kind of expanding and weathering it as well. And that breaks up material. So weathering is the breakup of material, and that's breaking up the material on these cliffs, and it's why every now and again we have big cliff falls. And when that weather material becomes unstable, it moves, mass movement, and that brings it down. So that would be another input into this system. And obviously geology is really important in this, and I'll talk about that in a second as well. So that's our marine processes acting here, affecting our sediment cells, our weathering, our subaerial process, our mass movement, bringing in material, and then also our fluvial processes. So again, erosion, transport, and deposition from the rivers, bringing in sediment, but also carving out here. They're eroding through this bit. If we didn't have a river, this would have filled up and we'd have a lagoon in here. So that's kind of important too. So linking in our sediment cells and our processes. I did mention earlier we could have glacial. We don't in this area, and we haven't really in sort of known history, but there are places up if you went round, and we could do a similar map for like the Holderness coastline up on the kind of north of England. They did have glacial input as well. So we've thought about sediment systems, our processes, and then also want to think a little bit about our sea level rise, because that's quite important. So sea level rise is caused by climate change, and climate change can either be human or physical. So in the past, the climate's changed lots because of physical things like the Milankovitch cycles, like sunspots, volcanic eruptions, etc. They naturally change it. And all the previous, everything before 200 years ago, climate change happened was actual natural. So it got colder because of Milankovitch cycles, and that meant that more rain fell as snow, and we had ice on the land, and then basically the sea levels went down. And that would have caused some of the sort of raised beaches that we find right over here in kind of Portland, because the beach was here and then the sea level went down and it ends up miles away. And then when the sea level rose again, it forms some of our like submerged coastlines. And actually a really good example for you to think about is Salcombe. Salcombe was a river coming in like this, and then basically it was a river valley, it got flooded. Did not happen here, it's not what happened here. But it got flooded and made the Ria. So that's why we kind of get the Ria, because of the sea level rise. Sea level can also bring in these kind of sandbars as well and can change the coastline. It can bring in beaches as well. So we do need to think a little bit as well about sea level changes. That's also important to think about as well. And while we're there, I suppose the last thing to kind of talk about, and we kind of think about this as a system, is obviously any other sort of physical factors. And a really big one here is the geology. So that's really significant, because if the geology is weak, like it is here, and things are easily eroded, we'll get a big bay forming. So geology is really kind of important. If this was really hard granite here, then it would be very hard for this river to actually get through. If the rock was really, really hard, then it'd be harder to erode, so we wouldn't have as much erosion and we wouldn't have as much sediment for these beautiful sandy beaches. So these beautiful sandy beaches tell us the geology must be a bit weaker because we've had lots of erosion to produce the sand. If we come to over here, we've got harder chalks, which means that they are eroded more slowly, but it does mean that we can kind of get sea stacks. And that's really important. And think about the climbing I've done recently on sea stacks. The rock has got to be fairly hard, because otherwise when it was eroded, it would just collapse. It's got to have enough strength that it can actually form or can stay upright in terms of the sea stack. We'll have a nice little sea stack here. So that's looking at the side. One of the ones I climbed the other day, the Old Man of Hoyt, what helps it is that it's got a really hard rock at the bottom. So the sea can't erode this bit, so this sort of sandstony bit ends up staying higher because it's protected by harder rock underneath. But if we had really soft rock, like we have in this sort of area, we wouldn't get any cliffs and we don't get any sea stacks and arches because they just get removed too quickly. It's got to be fairly hard. If we go all the way down the other end and go to Cornwall, right down here, we've got lots of granite, which is so hard that it doesn't really erode and leave stacks generally because it's just too hard to erode and it's very slow to erode. So it's less likely that you'd get those. You need kind of middling hardness to get the sea stacks and the arches. But that's how our kind of landforms would form here. So geology really important. If we go down here to Bournemouth and further down, we get to an area called Barton-on-Sea. And Barton-on-Sea has really weak materials that erode really, really fast. And the problem they've had here is it used to have a beach, but to make sure the beach stays here to protect this area, they've put these groins in. And when the groins stop, over here, it's actually quite a bit further to be honest, but over here the groins stop and there's no sediment coming into that system. So the beaches have gone out of the system and you're left with very little beach and natural protection. So there's been more erosion taking place. And that was an unintended consequence of what they've done here. They didn't try to screw over Barton-on-Sea, but when they stopped putting the groins in, the sediment just disappeared because it was being held here and the input was lost from longshore drift and there was only an output on Barton-on-Sea to the next place. So that helpfully kind of thinks about these key things. And all of these things are kind of important together. And you've got to think about them as like a combined system. Sediment systems have inputs and outputs, and the inputs and outputs are kind of provided by the processes, the fluvial, the marine, the subaerial, the glacial processes. And they're complemented by the sea level changes, which can affect what actually happens because of the level of the sea. And then finally, they're affected by the geology, because if the material or the land is really weak, then you will have lots of erosion, and that will then actually lead to lots of deposition. You'll have different landforms. If it's really hard, you'll get more resistant landforms like you do over here. And what's interesting about this area is that there's lots of different layers of geology, so lots of different rocks. That's why the Jurassic coastline, which kind of starts here, is so famous, because it's got all these different layers of rocks that were laid down over time, like in different layers like that. So that's kind of the bottom and that's the top. They were laid down like that. There's as much geological history as there is in the Grand Canyon in this bit of coastline. And then the whole thing was rotated round, so the layers of rock end up like here, 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 here. So we get this massive range of different rock types, which means we've got headlands and bays here, we've got this river inlet here, we've got big beaches here. And that's what makes this a special coastline, because it's because of the geology, meaning there's lots of variation. If it was all the same, like Cornwall, it would be quite different from here, because it would be very samey. This has got lots of features because the geology is very varied. Hopefully that gives you a bit of an understanding of the kind of overall basics.